Hello everyone, this is Bradley. Today this is a tutorial talking about this shield effect I've done quite a while ago, and I revisited that to simplify and optimize the workflow so that this can be potentially made into a tutorial like what we are doing today. I'm not going to cover everything because certain things are still under development, but I try to cover most important concepts which is available now. So let's start. So here we're in Blender. As always, I'm going to use the presets which you can download for free from the link in the description. Let's start with a plane to hold a geometry node tree, and we need a basic simulation to emit particles. Let's start with a grid which we can use to emit particles, and I need a simulation zone. I need to join particles, and we point to distribute. I'm going to keep the point amount low, and then we set position to add this velocity. We can use the normal to emit these particles. So now if I lock this interface, and if I look at this animation, you can see it's oh, I set that to position. It must be offset. So you can see this particle is being emitted. Let's increase the time range so that we can see this animation endlessly. I'm going to change the seed for it. So take the time frame. We're emitting different particles over time, which is cool. I'm going to change the orientation of it. So let's use this empty. Let's name that as an emitter. And I'm going to change that to arrows so that I can know where my z-axis is. And I'm going to parent my grid with this emitter so that I can move this emitter and orient so that it can shoot particles in the way I'm looking for. I'm going to decrease the amount of emission. So this amount is kind of low. Let's decrease the join interval. Maybe every 15 frames I'm joining one particles, as you can see. So we have less particles being generated. I'm going to turn down the direction variance for the moment, just to make the effect a little bit simpler. Okay. Then let's talk about the collision. The principle of this collision impact is quite straightforward. There are many different ways to do it, but there's the traditional way will cost a lot of performance using the repeat zone. So it was not really ideal. So we are going to use a more kind of a cheating method. And fortunately, it works well in eevee. So here, let's go with a UV sphere. And we need a UV map. So store UV map. To take this UV map, and I set material to look at, I need a material. So just to get an emission shader, we get, let's name that as impact wave, whatever. And you may can actually visualize this UV map. So UV map viewer. Yes. So now you can actually see we have a sphere, but if you look at its UV map, it's kind of 0, 0, and 1, 1 range. Okay. What I want to really suggest is that this UV map is being stretched. Okay. And you will see the effect of its stretch later. So here, let's go to our shader editor and to look at our material. Let's import this UV map, and it's not really. Did I set a material? Oh yes, I need to set a material. Yes, this is not really understandable. So we are going to use a gradient texture to look at the spherical geometry, and we're going to offset this UV map So instead of making the center located on the pole, we're going to subtract 0.5 and scale that down so that we can read that. And now you can actually see that this sphere is actually being stretched horizontally. As I mentioned, that this UV map is being stretched. Okay, so we are going to multiply to offset this stretch. And I think we multiply 2 on the x horizontal axis. So now you can actually see this effect. We have this expanding sphere. Okay, and basically what we are going to do is just to expand this sphere, but we also need to create a hole in the middle. There are many different ways to do. For example, you can subtract another sphere with these coordinates. But the way I'm going to do here is that I'm just going to do a color ramp. And I'm going to make it mirror. And just for convenience, because I do not want to create multiple tags, I'm just going to use one tag to replace everything. And by sliding it, this black one, you can see this is how it looks. So now if I animate this ring, then you can see there is an expansion effect. Okay. And basically we are going to make it transparent. So I don't share my presets of shader, so we have to do this from scratch. And it's actually pretty simple. How to do that, by the way? Oh yeah, we have a transparent BSDF, and I mix shader. Plug that into the factor, and we probably need to reverse it. And remember to make it into alpha blend. So yes, we have this effect. You can make the other one into emission shader. If you are going to turn on bloom, it can work more interesting. But anyway, I'm not going to do that now. And then we are going to put noise onto it. You just there are essentially many different ways to put a noise on shader. I'm just going to add a noise texture. And this is annoying. Without the presets, I'm going to denormalize that. Color, scale, and plug that in. So this scale is too large. Just decrease it. And yes, basically this is it. So you just expand and you get this effect. Okay. It's very unfortunate that we are working with coordinates for the texture. That's why sometimes the scale is very intuitive, that which is unintuitive, that by increasing up the scale, we are actually scaling down the texture. So you are going a reverse order. But basically this is what we are going to eventually animate. So we finished the basic unit, and the rest is about instancing this stuff based on the collision status on our sphere. Next, let's generate our UV sphere for shield. You can use the same UV sphere, but I will just duplicate one. There is no real reason for it, simply because it makes me comfortable. And we're going to detect the collision. So there is a collision in ray. It's essentially just a recast node. As you can see that their outputs are basically comparable. There are only some special settings with this collision in ray. For example, we have a hit distance, which is function in this is hit, so that we are constructing a detection margin. And I also have a default input of direction as a velocity. And we already constructed this velocity using this normal, save that as attribute v, and we're using this attribute v to drive the set position. Okay. And so now let's firstly preview our animation. As you will see that I have these particles, which is too slow. I'm going to scale that up maybe 5 times so that it becomes faster. And now we can take a viewer to look at this easy hit. So you can see they are black, which means there's no hit. But when they are closer to the sphere, then they are shined to be white. And we basically need to separate these particles based on this hit status. So we select out these particles which is not being hit. And then we output that. So now if we look at this animation, you can see that these particles are initially being emitted, but once they hit this sphere, they are getting deleted. This is okay. And for these particles that hit our UV sphere, we are going to join particles again. And let's plug this inverted into new particles, and we need to join particles on the new simulation zone socket. And let's just join geometry to look at the result we have so far. And I'm going to plug this into let's go below. Okay, so now if I play this animation, you can see these particles get stopped once they detect this collision. You can make this collision margin a little bit lower. I think I'm going to change the default after this tutorial, but anyway. So you can see they are not really setting on the surface. We can set a position to really make them to hit the surface. Okay, so now you can see these particles are really staying on the surface. And I do not want to create a duplicate if they are already passing through this UV sphere. But it probably does not really matter. Okay, I think this setup is kind of okay already. So let's hide our shield. We are going to instance our previous animation onto these particles on surface. So let's take an instance on points, and we will see it. So this is what we are looking at now. You can see this UV sphere is being spawned on the top of our shield. And this is actually the plan. So instead of making the shield shader itself having different expansion of wave impact, we're instancing wave impact with a time offset onto this setup. Okay. So this is the principle. And the way we're going to change this animation is firstly we need to orient these instances to our shield so that it does not really stand out. Otherwise, if you look at the material preview, something looks like this now. Okay. So here, if we look at this material preview of our impacts, you see this UV sphere origin is pointing to the X. So we are going to firstly origin offset to the negative X, so that this UV sphere will always be on the right of the origin, no matter how you actually scale that up and down. And then we are going to instance and align this rotation to a vector on the x-axis. So in 4.2, this will be align rotation to vector. But anyway, and then where we align to, we align with the normal of our shield. So you can take a sample nearest surface with the normal. It's possible that you use the hit normal as well, but I'm not going to do that here for the reason which is difficult to explain. Anyway, so now if I play this animation, you can see this is how it looks like now. And yeah, we have this non-animated impact being instanced onto our shield. But this looks kind of a wrong direction. Can I just invert rotation? Yes, if I invert rotation, then you can see this is covering up. Okay, it's not. Let's rotate rotation. And going with 180 degree. So now they are really overlapping to each other. And this is the effect we're going to have. So let's create some shader for our shield. Otherwise, this is so ugly looking. I'm going to create a shield material. So the material for shield. And basically for our shield, I'm going to make a transparent alpha blend. Let's say mix shader transparent BSDF, and we take a first nail. Now it's called layer weight. We have facing, color ramp that. So we only shows on the edge, and we plug that into the factor. The white part will be emission, and now this looks like the shield. We're going to set shaded smooth to remove these kind of weird polygons. Okay. So now we finished our shield. We need to finish the animation of our impact wave. And the way to do that is that we already have a recorded time or the birth date of these particles upon joining, and we can use this time to construct a particle age of it, and then we can use this age to construct a fall from 0 to 1 based on duration, and to scale these instances. So let's store a named attribute, and let's name this as a fourth. So within our impact wave material, let's take this attribute f, and we are going to scale this impact wave accordingly. As you can imagine that we are going from 8 to 1, I guess. So let's go with the map range, and we are going to reverse from 8 to 1. And now if we play this animation, you can see it's not really working yet. Why is that? Oh, because we are working with the instances. Okay, so the attribute should be instancer. Okay, so now if you look at this animation, you can see this is how it looks. It's not really completed yet, but this is the status now. So several things we're going to do. One thing is I'm going to interpolate this fold. So the expansion should occur pretty fast with this float curve. And let's again decrease the amount of particles that we hit. Maybe we only shoot one particle at a time. So now you can see this fast expansion. Okay, and we need to delete or make this wave disappear. And the way we're going to do that is basically multiply a number. Let's make it multiply 0. So initially you have this impact occurred, and we just decrease its transparency. You delete that. This is one way. There are many different ways to do that, but I think this way is good enough. And we basically float curve to make this happen later. And we do another map range. This time this is going from 1 to 0. So now if I look at this animation, it looks like this. Okay, let's make it disappear even later. And I noticed that I should not interpolate inside the geometry nodes. I should interpolate that inside the shader. So now it looks like this. Okay, so I think this is basically finished. You can tweak a little bit more of how things actually goes, and you can even increase the value 15, and you can also tweak this color ramp. And basically this is, yeah, you can add a different noise to it. It may not be very obvious, but they are using the same noise texture. If you want to add some variances, or if you want to animate this noise as you're expanding, then you can always animate these factors. And you can definitely use the same factor to animate this vector so that you have an animation or you have differences. But basically what I want to introduce you that is that if you use an ID, which is also stored with these join particles, then you can add a different noise for every of them. I failed, did I? Why it doesn't occur? Oh, let's use a white noise. And now if I play, yeah, it works now. So anyway, it's just a kind of idea. And basically this is it. You can use this white noise for different colors as well. Can I mix color? And we can mix different colors with our shield impact. So some of them is green, some of them is red. Let's just increase the strength. And bloom yet. And yeah, basically this is it. Let's decrease the time for range or duration. So you have this impact going up. So this is really just an idea. I'm not going to optimize the looking here. As long as you get the idea, then it's fine. Next, let's finish more about this setup. We are going to join back our initial particles. And I'm going to take an instance on points. Let's instance rod, which is basically a capsule or bullet, whatever you call. And take that into the instance and join this geometry. And now if I play this animation, you can see this capsule or rod is hitting our shield, creating this impact. The orientation is obviously wrong, so we are taking the align rotation to velocity and take a value precision to the scale, and it basically it's okay that this particle is hitting, creating the instance of impact wave, and we want some deflection of these particles. I talked about all these kind of deflection particle things in the past. Today we're going to do something, however, different. Basically, what I'm going to do is to do that in simulation zone instead of outside simulation zone. And the way we're going to do that is basically very simple. We just duplicate this drawing particle, and we create new sockets of particles in simulation zone, and I join these particles with the initial bullet so that they can be shared with this rod instancing. And now if I play this animation, we do not see these particles. We are going to set position, and we need to add a velocity along with the normal. So we store the normal where we hit. As an n, and then we call that, which is a vector, goes to velocity, offset, and now if I play this animation, you can see not only this particle hit is creating the impact sphere, but it's also reflecting or deflecting the bullets. Okay, the bullets amount being reflected is kind of low, so we're going to take a duplicate elements, so increasing the amounts. And fortunately, because we have built-in velocity variances and direction variances, then this bullet is actually having different parameters automatically. The nice part of having these presets, simplifying the workflow. And we are going to add some gravity. In the past, I talked about the gravity based on the data time, but the clock for these particles are different. So instead of using these gravity methods, I'm going to use a different method, which is cumulative force. You do not really need to understand yet for now, but just to know that this is essentially just a store named attribute, and we are adding the attribute to itself using this whatever stuff. Okay, and here we're going to add gravity, which is a negative 9.8, and we plug these gravity forces with the velocity into the offset. So now if I look at that, you can see this is dropping like the gravity. It drops slowly first, but then it becomes faster and faster because this is the concept of gravity, which is an acceleration. We are going to decrease the scale of this particle size. And basically this is what you saw earlier, that we have a time for. And we're basically using the same concept. And if you directly plug this fourth into this value position, you can see it becomes larger and larger. So we remap 0 to 1, reverse the relationship so that you hit it becomes smaller and smaller. Maybe change the duration longer so that it lasts longer. But here you want to be aware of another thing. That's because we're sharing the initial bullet with reflected bullets in this instancing. So if you scale one, you scale another at the same time. So here we are going to make a cheat. Then I'm going to capture an attribute and I only boolean 1. So that only this branch know that it's being selected for this switch. And the other one will use the false number. So I'm going to hit that to 1. And if it's known to be this branch, then it will use this time fourth. So now if I play this animation, you can see this is how it looks. Okay, this is looking cool. The only thing is that I need to scale the normal a little bit more. Maybe 5. Then something like that. Okay, let's increase the direction variance to be a little bit more, maybe 12%. Yeah, something like that, whatever. And you can tweak all these kind of parameters. The only thing I'm not going to discuss is the reflection on the ground, because I haven't really finished that part myself yet. It's not ready to be shown in the tutorial, so I'm not going to show that. But I think this is already good enough. If you look at the material preview, then you can see this is how this animation goes. Let's add a set material for our bullet. And the emission. And let's increase the strength. 35. Then we have this result. Okay. At last, we are going to make this setup a little bit more interactive. People once complained in one of my simulation nodes tutorial that you can fake the animation without simulation zone and without all this kind of complex whatever stuff. It's kind of true, but it's also kind of wrong, because you always need to think why simulation zone is needed, why developers add this simulation zone in general. Because you can actually fake a lot of the effects without the simulation zone. But at the end of the day, the fake simulation is fake. So you cannot ensure the actual interactivity if you are moving your characters or doing other things. Okay. So we're going to really make this effect onto a simulation only status. And here I'm going to basically parent our shield with something else. So let's take a target. This is another empty. And we take a parent with our empty. So that if I move this empty, then the sphere moves with that. And let's take a default cube or Suzanne monkey, and I'm going to get a constraint. You can actually parent with it, does not really matter. Copy location with the target, or you can parent with that the child of copy would transform. I do not really care, but you get a kind of idea that I'm using a single empty to move this setup. And I basically want to do is to ask these bullets to track our Suzanne head. And basically the way I'm going to do is to, let's say, not to affect the rotation, because I need align rotation to vector. We need the position of our emitter to subtract the position of our target to create this rotation, and we transform it. And it goes the opposite. Let's reverse the subtraction relationship. And now you can see it's actually following my Suzanne head, but it's kind of slow responding, but it's working. Okay. If you want to add some inertia, I don't know how to actually call that, but basically when you're trying to aim a moving object, you want to aim the direction where this Suzanne head is moving. So you are targeting here if this Suzanne head is moving to that direction. And then we can have a temporal object info, and I think you can add the velocity to it. And take this empty. So that it potentially will hit the Suzanne head. And this velocity may not be large enough. Let's multiply with 5. Okay, that goes in the opposite direction. Let's subtract it. So now this is too much. Let's decrease the rate. Okay, so finally it hits a moving target. Something like that. I don't know how machine gun really works in such a kind of case, but try to tweak these values. You will find something that works. And to make it more interesting, just increase the whatever stuff. Let's increase the variance back so that we finally have whatever stuff being made. For emitter, no, for target, we can actually increase the scale so that you have all this kind of whatever stuff being made. Let's decrease the scale a little bit. Yes, something like that. And the last problem that you will find is that this, because we're moving our targets, so the initial instance, the location, based on the recasting, will be disconnected from the moving target. That's why it's showing on the space, but it's not really sticking with the surface. So sometimes this is expected, especially for this kind of deflected bullets. It's expected, but for this impact wave on the shield, then you may expect this effect to actually follow the target. So we're going to fix that. To solve this problem, it's quite simple. I've talked about the concept of dynamic surface sampling in the past, but this node is not directly usable here. This is only because for different particles we have a different frozen state to sample from. So we have to do that a little bit manually. Let's take a simulation tool. And I basically import the current state of my shield. And then this simulation output will feed back its output to the simulation input. And we are getting the previous frame of itself. So now we have the current state and we have a previous state. So this is the starting point for us to do dynamic surface sampling. So because we already set position with this recast, it means at this current moment, this point, if it hits or detected, will definitely sit on the surface of itself. And the next frame, it will still sit on the surface on the geometry from previous frame. So we are going to sample nearest the surface from this previous frame. But we are loading the information on current frame. And so we sample index, we sample the current position of our current geometry based on the index. This index is the same because these two are essentially the same geometry, but they are just at a different time. And I capture these results for this geometry, and I pass this sampling result to my particles. So I set position and to the position. Okay. And yes, it will just be fine. So now if I play this animation, you can see this wave is always on the surface of our shield. If you do not do this step, then you will see it's always disconnected to each other. So we made it work. And basically this is it. And yes, I think I finished everything. There's probably nothing I can really add now. This isn't really complex setup because of the presets. If you do not have presets, I cannot really imagine how many nodes you actually take. But anyway, I hope you enjoyed this video. I'll probably see you next time. Bye bye.